We are on this section about function. So last time we have one example about function using def. So def is a keyword to make a function in Python. And when we define the def, we need to follow it with the function name. So the function name can be anything. Let's say in this example, I use display. So this is also a kind of identifier. We call this is identifier. If you still remember, identifier. We need to make identifier unique, and it should start with alphabet. It can be started with underbar. It can be started with $sign, but not with number. Okay, so you already know those things. And we cannot use the reserved word or the Python syntax. Let's say if you want to make def continue, okay, then the name will not be available because continue has been set up for the Python syntax. Okay. And you can also define the function, a function without and with parameters. The meaning by the parameters means what is inside in the parentheses. So in this case, I would like to have one parameter. So one parameter here I define with a variable char. This is also another identifier. So the identifier should be unique and it should not use the Python reserved words. So we can say that this is a variable name, and whenever we type the parameter in the parenthesis like display Yongin, then it will be sent to this variable, and then whenever we have any statement inside this function, then it will be executed. So for example, calculate. Okay, so I want to have 5 comma a comma b. So I want to have the print a plus b. So I want to do the calculate 5 comma 3. Then it will give you result a. Why? Because we have the calculate, which is the name of the function, and then I have 5. 5 will be sent to the variable a, and then 3 will be sent to the variable b, and then I want to print a plus b. So I want to print 5 plus 3. Then the result will be 8. Okay. You can add those parameters as much as you want. You can have one parameter, you can have two parameters, you can have 3, 4, 5, and so on. So this establishes a new identifier as the name of the function, let's say count in this example, and it establishes the number of parameters then that it expects. And we will define its function signature. So we call this is the function signature. So in this case, I would like to have a function name which is count1, and I have two parameters. The first parameter is data and the other parameter is target. Now, I can define this parameter as any data type. For example, now I want to specify n equals to 0, and then I would like to look. Okay, so I hope that you already know, look for number in data. So the data is from this variable. So for every number in the data, I would like to check if the number equals target. So the target is from this data. So if it is equal, then let's do this one, n plus equal 1. Do you know what is n plus equal 1? This is n equal to n plus 1. We will add by 1 for the old value of n. Because the old value n is 0, then the new n will be 1. Okay. So after we finish with the loop, if the condition is true, it will be added by 1. If we finish with all the loop, we will print n. Now, what is the result? Count 1, list 1, 3. Okay. Yeah, 1. Because number equals to target, it means list 1, it contains 1, 2, 3, 4, 5. Okay. And then I would like to check if the number, which is the element in the data is the list. So if the number equals to the target here is 3. So if the number equals to 3, let's check. 1 equals to 3? No. 2 equals to 3? No. 3 equals to 3? Yes. Then n will be added by 1. And then it goes to the next. 4 equals to 3? No. 5 equals to 3? No. Then we find only 1. So n will be added only 1 time. So if we print n, the result will be 1. So you can try. Okay, the result will be 1. So yeah, please try to understand. There will be quiz about this one on the next class on Wednesday. For maybe the learning check. Okay, I will not do the quiz, just learning check for this problem. Now there is another code that we can do with the same problem, but now I am going to use return statement. I am going to use return statement. What is the difference? In this statement, it is the same. This statement is the same. This statement, it is the same. This statement, same. This statement, the same. But at the end, I want to print. In this function, I want to return. What is the difference? So if I run this, actually it returns the same, 1. The only difference is, if you check this one, and if you check this one, if you see this cell, it means the variable, I know that this variable, but it will not be shown like what you see here. You will see this one, it is the result of print. But you will see this one, this is only in the what we call as the memory address. Okay. So let's say I want to make the count to into one variable. So I have a variable A and I want to put the result of this one into the variable A. So I can run this, and then when I print A, I know that the result is 1. I can specify it into the variable A. But in this case, you cannot assign it. So you just can call the problem. Okay. Yeah, the result is B is this result is 1, but B nothing. Okay. So this assignment, the assignment to one variable you can use with the return statement. But if there is no return statement, you cannot assign the result to a variable. So the return statement returns the value for this function, and 10 minutes it's processing. Okay. So the parameter pass, we call it the information passing in the function. Parameter passing in Python follows the semantic of the standard assignment statement. So if I define list1, then yeah, it will follow the list1 is a list. The target value is just an integer. Okay. So this variable is very flexible. I think if you learn Java, you need to define its parameter with their own variable. If you specify this one as integer, then you need to type this one as integer. If you want to specify this one as float, then you need to define this one as float. If you want to define this as string, you need to define this one as string. But in Python, you do not need to define the variables. I think you already know the simple output. We use the print usually to represent the simple output, and it is used to generate standard output to the console. In its simplest form, it prints an arbitrary sequence of arguments. It is separated by space and followed by a trailing new line character. So for example, if you use maroon, 5, the output will be maroon 5, and then there is like \n. It means it will go to the new line. A non-string argument x will be displayed as strx. So any numbers like this one, it will automatically change to string. So if I have the print of 5, then it will go to the next line after we print this one. You can have like half \n, 5. If you have this one, then you will print half. It goes to the next line, and then you will print what is the next character or what is the next element. In this case, after half, and after I go to the next line, I want to print 5. there is one command or one syntax in Python when we want to get the user input. The primary means for acquiring information from the user console is a built-in function named input. This function displays a prompt. If given as an optional parameter, then waits until the user enters some sequence of characters followed by the return key. The return value of the function is the string of characters that were entered strictly before the return key. So, for example, I have its, and then I have input function. What is your its? So in Jupyter Lab, in Jupyter Notebook, it will give you the question, what is your its? And now it is waiting. What is your answer? So let's say I give 5. Then I can say the its is equal to 5. Because what you input in this section, it will be saved into the variable its. Now, I want to know what if I want to plus the its with 10. Oops, error. Why? The error message says that can only concatenate str, not integer to string. So it means this is a string. You cannot add string with integer. It means this input, it is only for string. So how if I want to change it to integer? Then I need to put the its equals to integer. I need to convert the data type of string into integer, and then I can again say the input from the user. What is your its? So I can get another question. What is your its? Let's say I have 10. Okay. Now I can print its. If you see the first its, it was written in between the single quote. The single quote means string. After we put the int integer, then the value becomes integer without single quote. So it is already in form of numeric. So I want to plus 8 with 10. Then it works. 8 plus 10 equals to 20. Okay. Now let's have a program. Okay, let me just use this one. So I have its. I want to input it as integer, and then input, enter your its in years. And then after I have the its, I want to calculate the maximum heart rate equals to 206.9. minus 0.67 multiplied by 8. And then I have the target equals to 0.65 multiplied by maximum heart rate. So print your target fat burning heart rate is the target. Oh, I have to problem this one. Okay. So what will be the result? It will show what is your maximum heart rate according to the your age. Okay. So if I enter this one, enter your age in years. So let's suppose I'm 20 years old. So in order to have the fat burning heart rate, you need to have the heartbeat, maximum heartbeat is 125. So this is the problem, the equation from the medical science sport exercise. So you can write your formula like this one. Okay. Every numbers, you know that this number is in the form of integer. When you multiply with float, then the last number or the result will be in the float. Okay. Okay, now we can connect our Python or Jupyter notebook file with another file. So files are opened with a built-in function open that returns an object for the underlying file. For example, the command fp equals to open sample.txt attempts to open a file named sample.txt. So there are some example to call the file with read k, read line, and etc. So let's see. I will open the file. Here you can click plus. You can add any other files. You can add notebook files. You can add console. Console means the terminal of Python. You can add other kind of file. So you can add text files, you can add Python file, and etc. So let's suppose I want to make text file. So it will show you a new panel, and then you can have any data that you want. Let's say I want to make like 2, 3, 4, 5, 6. Okay. And then I will make the file name change into sample. So if you want to change the file name, then you can go to this section because it is related with the file. If you want to add more things, you can relate with this section. So when you rename the file, then the file name has been changed to sample.txt. Now I would like to teach you how to open a file. I will use fp. Actually, you can define any variable name. I want to open the sample.txt. Okay, I think as far as I remember, we need to put the R. It is to read the file. R means read the file. So what I want to read this one is okay. Make sure that you save the text file. Okay. If you don't save the text file, maybe it will not appear the result. So when you open this file, after you finish with the information 2, 3, 4, 5, 6, please press Ctrl S. Okay, yeah, you can just save text. Okay. And then you can move back to this notebook, and then you can write the syntax. Open sample.txt, and then you just want to read the file. And then you can call the file, which is in this variable fp, and I want to read it. What does it mean by this? Two, and then \n. It is the next line. Okay. And then I have another value 3, and then \n. So it goes to the next one. And all of them are in the form of string. Okay. We can also use for loop. I want to use fp, and then I want to print for every value in the file. Oh, sorry. So this is a limitation of the read file. After you read it, then it will go to the last line, so you cannot read anymore. So if you want to read again, so you need to open again. After you open, then you can again read the file. Okay. So it is one time read. After you read, after it finishes, then you cannot read again. So you need to call again the variable in order to open the file. So you can get the result like this one. So this is the meaning by read file. And you can use other syntax, for example, read lines when you have multiple lines, you can read line. And then you can check what is the line. Okay. You can iterate for every line. You can seek, tell, write, yeah, and anything with the text file. Exception handling. Exceptions are unexpected events that occur during the execution of a program. An exception might result from a logical error or an unanticipated situation. In Python, exceptions are also known as errors. Usually we call exception, it is related with errors. Exceptions are objects that are raised or thrown by code that encounters an unexpected circumstance. So the Python interpreter can also raise an exception. A raise error may be caught by surrounding context that handle the exception in an appropriate fashion. If uncaught, or if we cannot get the error, then the exception causes the interpreter to stop the program. So if you have a very long program and then suddenly you have error, then your program will be stopped. In order to avoid that kind of stopping program, you can use the exception handling. So there are some common exceptions, or there are some common errors that Python already defined. They have the class exception, they have the attribute errors, EOF error. EOF means end of file. IO error means input output operation error, and so on. Okay. So we can look at some details like zero division error or value error. When you have the function sqrt minus 5, it is value error because when you use the square root, okay, sqrt, it means square root. When you want to calculate the square root, it is impossible with the negative value. So it will be error. Or zero division error. Every number divided by 0, it is always error. Okay. So when you want to do the exceptions, you can use the raise statement. Okay. There will be raise statement with an appropriate instance of an exception class as an argument that designates the problem. Okay, let's see. I think I have the, okay, I have the information here. So if we have the exception, we can try with this try block. Okay. Or, okay, let me show you with examples. X, let's say -1. And then, let's see, if I have sqrt x, I need to, okay, maybe I will explain this one later with the math function. If x is less than 0, I can put the raise value error. X cannot be negative. Can you see? Whenever you have the error message, you can define the error message by yourself. Okay. This is the error message that you define by yourself. X equals to -1. If x is less than 0, then show this message. Okay. So you can make your own error message. The value of x cannot be negative. So it will be changed according to your error definition. Okay. And let's say I have a equals to 5 and b equals to 0. And then I know that if a divided by b, sorry, a divided by b, it will be errors. And the exception is zero division error. But you want to make your own definition of the errors. So you can make something like try, and then you can make your problem. Okay, let's suppose I want to have this as the error. Okay, I know that A divided by B is always error, and it's already defined by the Python. But I want to create my own error message. So I can have this one. Maybe let me make a new variable. So try ratio equals to A divided by B. If we have the except as the zero division error, you will print you divide a number with 0. So what you can see here is your program keeps running. There is no error message. But it will just show you a message that now you are running a program and it contains an error, which is zero division error. And this message is to show that you make a wrong input, but the program still runs. Okay. So that's the meaning by the try except or the exception handling environment. Iterators. Basic container types, we call it the basic container type like list, tuple, set. Okay. It qualify as iterable types. So which allow them to be used as iterable object. Let's say you use for. But there is another kind of iteration. We can have the iteration for every element with a variable. For example, if a variable I identifies an iterator object, then it's called to the built-in function next I. It produces a subsequent element from the underlying series with a stop iteration exception race to indicate that there are no further elements. So maybe I can show you with examples. I think you already know if I have 1, 3, 4, 5, 6. Okay. You know that for I in C, print I. You know that we want to iterate for every object in the variable C. But now I want to check each of the item. In this case, I cannot check each of the item, so it will show you all the items directly. So I can say like this one, I is the iter C. It means for every element in the C, it will be iterating. So what is I? We cannot see because it is a kind of list iterator. What we can do is to check what is the next I. The next I is 1. So we will do something because now we know that I equals to 1. And then I can go to the next I. The next I is 3. So I can do something when the I equals to 3. And then I can do again next I. Now I equals to 4. So is it possible to go to the next? Okay, because we still have another element. Is it possible to go to the next? Yes, because we still have another element. Is it possible if we go to the next? Now it has an error because the last element is 6. So the iteration will be stopped and it shows the error message. It should be stopped, or there's an error message, stop iteration. Okay. So the generators is almost the same with the iteration. Okay. It is the most convenient techniques for creating iterators in Python is through use of the generators. A generator is implemented with a syntax that is very similar to a function, but instead of returning values, a yield statement is executed to indicate each element of the series. So for example, I have this one. Okay, let me have def factors and so I have for k in range, I have 1 until n plus 1. If n remainder k equals 0, then yield k. Okay. I would like to start from 1 until n plus 1, n will be defined. And for every n that is divided by k equals to 0, it means if n can be divided by k, then let's save the k. So let's say I have factors 10. The result is not a number because this is the generator. So I save the value in the generator, and then what I can do actually, I need to put into a kind of variable factors 10, and then for every C in V, I want to print C. So I can get the result if I do a loop or if I do iteration on that variable. So V is a generator object, and I need to do a kind of loop in order to check the result of the iteration. Okay. Okay, I think it's the time. Any questions?